Hey guys, welcome back. All right, so in the previous section we talked about horizontal and vertical translation. So it's when they happen when you shift a graph up and down. Next topic is going to call reflections and stretches. So first one, this we actually covered this in a lot more detail in chapter 2 as well. This is what we call y equals square root of x as a radical function. So obviously, guys, for a radical function over here, we have some conditions here. We're only allowed to take square roots of negative numbers. That means x has to be greater than or equal to 0 for this type of function here. But if I put an x equals 0, square root of 0 is 0, square root of 1 is 1, square root of 4 is 2. So these x values were chosen carefully because they're all perfect squares here. So this graph is going to look something like this. Like that, okay? So this graph is going to look like this radical function like that, okay? All right, so the transformation that we're looking over here is what happens if I take this x and replace it with a negative x, okay? So for y equals square root of x becomes y equals square root of negative x, okay? Well, what we saw before is we have a bit of a conflict over here because we said that we can't have the square root of a negative number, okay? But what happens over here is like, sorry, I'm just going to copy these because they're the same that they were on the previous page. But we can have this negative here as long as this number over here is never positive, right? Because like if I take a negative and then put another negative number over here, the two negatives would cancel out. It would give us a positive underneath their square root sign, okay? Another way of looking at it is if we look at this guy over here. So if we have the square root of negative x equals a y value of 0, if I square both sides, I get negative x equals 0. That just means x equals 0. If I square both sides here, I get negative x equals 1, and that means x equals negative 1. If I square both sides here, and if I just keep following this pattern, you see they're the exact same numbers, except they're all going to be negative numbers instead of positive numbers. So on my f of negative x, which is y equals square root of negative x, I have same values over here, except they're all negative. Okay? So if we have this transformation where we have y equals f of x becomes y equals f of negative x, the mapping notation over here becomes negative x, comma, y. We call this a reflection in the y-axis. I'm going to show you in a second why. So like if this is my y-axis, and if I have this graph over here, well, if I make all of my x's negatives, the graph's going to look like this. So if this graph over here is the y-axis, this is like the line of reflection from this graph over to this graph over here. All right, so for example 2, we have two graphs over here, and we're asked to, so this is f of x, and we're asked to graph y equals f of negative x. And again, this is a reflection in the y-axis. Okay, so at this point, which is going to be 6, 7, 8, this is 8 comma 2, it's going to become negative 8 comma 2. This is 1, 1, it's going to become negative 1, 1. This point stays the same. We have a special name for this. We'll talk about that in a sec. This has an x value of negative 1. Now it's going to be positive 1. And this comes over here to positive 8 over here. So this graph is going to look like, this guy over here. Okay. If you're curious what this function was, this is actually going to be y equals the cube root of x. And so how this guy looks. Okay, so now we have this very strange looking graph over here, but all we're going to do is just want to be able to graph a reflection in the y-axis. So this guy's at negative 6. Now it's going to come to Sorry, my screen is very sensitive every time I touch it in the wrong way. Something weird happens. So this guy's going to come and be reflected here. This point of -5 is going to come to +5. This point is at -4, is going to become to +4 over here. This is -3 becomes to +3. This is just left of -2, so it's just to the right of +2 over here. It's reflected over here. So far, this graph is going to look like this. Okay. Okay. And sorry, this guy was over here, so this is going to be like up like this. Okay, so this is how the graph looks so far. Now this point is going to get reflected over here. This point is going to get reflected this way. This point is going to get reflected to here. So far we have this. This point is 5. It's going to be -5. This point is at 6. It's going to be at -6. And this graph is going to look like that. Okay, so this is how we reflect this guy. So again, the y-axis over here is our line of reflection. Okay, so the blue graph and the red graph are reflections across this axis over here. Okay, new function over here. So we have f of x equals 1 over x squared. If I put a -2 in here, -2 squared is 4. 1 over 4 is 1/4. Or -2 is going to be 0.25 as a decimal. -1 squared is 1. -0.5 squared is going to be positive 0.25. And if I go 1 over 0.25, I get 4. And I get these values over here. So you can see this in this graph this way. Okay, so this is what's happening. Now, what's different about example 3b here is like in the previous examples, we had the negative on the inside of the function. Now we have the negative on the outside of the function. Okay, so if I want to do a graph, so what's this guy going to look like over here? Well, what does -1 over -2 squared look like? -2 squared is 4, so I got 1 over 4, but the negative is still out in front. If I put a -1 over here, it's going to be 1, but the negative is still in front. So it's going to be all the exact same values that we had before, except they're going to be negative y values. So when I'm graphing this guy over here, this point, -2, positive 0.25 becomes, sorry, let me back up. -2, 1/4 becomes -2, -1/4. So that's going to be, this guy gets reflected down here. This point, -1, 1 becomes -1, -1 here. And so forth, this guy. So this graph is going to look like this. Okay, so it's the exact same graph except it's going to be this. So how do we call this guy? This one is going to be reflection, but not in the y-axis. This is now going to be reflection in the x-axis. So if y equals f of x becomes y equals negative f of x, we call this a reflection in the x-axis. We sometimes also call this a vertical reflection. It's called a vertical reflection because the graph was up here and now it gets flipped down here, so it's getting flipped in the vertical direction, and that's what we mean by that. Okay, so what's our mapping notation going to look like over here? So this type of transformation is not going to affect the x coordinates, only the y coordinates. So this is going to become x negative y. We call this a reflection in x-axis, or a vertical reflection. Okay, So what are each of these graphs going to look like? Okay, so in this graph over here, this red line over here is what we call an asymptote. Okay, so that means that this blue graph is going to approach the asymptote, but it'll never actually touch it. So if this guy is at 5, it's going to get reflected down here to -5. So we're going to have this dashed line over here. And then this graph is like above it over here. It's going to be switched to below it like this. Okay, this graph over here, we're going to get everything's going to be reflected in the x-axis. So this is going to come down to about here. This is really frustrating, guys. It's going to be reflected up here. So what we're going to see is that these points, which are actually on the x-axis, on the reflection line, are actually going to all stay the same. We have a name for these guys. We'll call these guys invariant points. And we'll talk about those in a sec. All right, so this is what this graph reflects is going to be. So hopefully if you kind of tilt your head to the side or just look at it, this is our reflection line here, the x-axis, and the blue graph and the red graph are going to be mirror images of each other in that line. Okay, an invariant point. It's going to be a point that does not move after a transformation. So what we saw in the previous example is that if I'm reflecting something in the x-axis, the x-intercepts will be the invariant points. If I'm reflecting something in the y-axis, and that's what this negative is doing, that means any point on the y-axis, or in other words, the y-intercepts, are going to be the invariant points there. Okay, so example 5, algebraically determine the invariant points if y equals f of x is transformed to y equals negative f of x. This is a reflection in x-axis. Therefore, invariant points are x-intercepts. Okay, so quick review. How do we determine x-intercepts? We want to set y equal to 0 and then solve for x. Okay, so if here's my original function, I'm going to make y equal to 0. So it's going to be 0 equals x squared minus 4x minus 5. Now remember, guys, this is a quadratic equation now. We need to be able to solve this. And we're going to solve this one by factoring. 0 equals x minus 5, x plus 1. Let's check this. X squared plus x minus 5x, x minus 5x is negative 4x, and this gives us this negative 5. So therefore, x equals 5 and negative 1. So we're asking for points here. So our invariant points are going to be 5, 0, and negative 1, 0. For part B, this is a reflection in the y-axis. Therefore, the y-intercepts are invariant. Okay, so the y are going to be invariant. So how do we determine y-intercepts? We want to set x equal to 0, solve for y. So if I have y equals x squared minus 4x minus 5, I want to make my x value 0. That means that y equals negative 5. So therefore, 0, negative 5 is invariant. Okay, so it's going to be the invariant point for this guy. Okay, so guys, I'm going to stop this video here, and I'm just going to restart it in a second here because this could be a good spot to stop, and we'll talk about stretches in a